Very briefly, I just thought I'd draw for you on the board what I was talking about earlier in the previous part of this session, where we were talking about the way that making one small change in a system can have a big impact elsewhere in the system. And the example we used previously was the idea of aspect. So I'm just going to draw some hills, and then here's a valley, some more hills, and for the purposes of this exercise I'm going to say that the equator is down in this direction, so that way to the equator, and the pole is off in that direction. So this is basically going to be the sunny side of the valley, and this is basically going to be the shadier side of the valley. So once we set up that system, can you now think through what the implications will be for lots of things that are going to be connected within that system? So I've given you just the bare basics there, the topography and the incoming solar radiation. Think of the other components of that system: the vegetation, the soil moisture, the surface runoff, the sediment transfer, gravity. Just do a little, pause me for a minute, go away and just do a little paper exercise thinking, well, what are the implications going to be of this setup? Then after I've run through this, you can also do it for different situations. So think of other environments or other topographic settings and think, well, what would be the implication of making this one small change? Suppose we turn this valley around through 90 degrees so that both sides of the valley were equally sunny during the course of a day, as opposed to having a shady and a sunny side. What difference would that make? Well, greater insolation on this side, so we'd expect maybe it gets hotter on this side, it doesn't get so hot on that side. That's one implication. In the spring, if there's snow everywhere, well, it's going to stay longer on that side and it's going to melt away sooner on that side. So surface snow is going to last longer into the season over there, whereas over here it's going to disappear more quickly. Also, it's going to warm up more here, so you're going to get greater evaporation and transpiration over here, so you're going to end up with a drier surface as opposed to a more humid or moist surface, regardless of the prevailing winds and the precipitation, which we're not really talking about now. I'm really just talking about the solar energy at this stage. But even just from the solar energy, you're going to start predicting, okay, we're going to have a warmer slope, we're going to have a drier slope. What's that going to do to soil development, and what's it going to do to vegetation? Are you going to have better vegetation here on a slope where there's plenty of moisture, or better vegetation here where it's much more arid? Well, you're likely to get better vegetation on the side where there's plenty of moisture, and probably less vegetation on the side where it's more arid, depending on your particular environment, but that's a likely case, especially since here you're losing the moisture earlier in the year, whereas here you're retaining moisture until later in the year. So if you have more vegetation here and less vegetation here, which we've inferred, we've just taken this one starting point, just a solar radiation starting point, well, when it does rain now, what's that rain going to do on these surfaces? We said there's less soil development here and there's less vegetation here, so the runoff is going to be much more direct on that side. Here we have more vegetation to maybe intercept the precipitation as it falls, and we have a thicker soil layer to absorb some of that incoming precipitation rather than it running off straight away. So we have more catching here and we have more runoff here. If there's more runoff here and less here, where's there going to be more erosion? Think geomorphic processes now. Well, you wouldn't expect so much erosion here because you've got the vegetation, you've got the soil, you've got the water not running off the surface so quickly. Here you've not got so much vegetation, you've got direct impact on the soil, and you've got lots of overland flow, surface runoff. So that's going to erode the surface. What's going to happen to that sediment that you're eroding? It's going to be transported and it's going to be taken down to the valley bottom. Maybe we have a river flowing down in the bottom of the valley there. Well, that's going to have this sediment coming into it from the valley side. Now, if there's more sediment coming in from the valley side than being carried away, what's going to happen to that sediment? It's going to build up down here, and the stream's trying to carry it away, but it's struggling, and so sediment is building up, and the stream is being diverted to the other side of the valley. At the same time, we've got erosion going on up here, and we've got deposition going on down here, so we have a change in the profile of that valley. On the other side, well, potentially here, we actually are starting now to get undercutting. So here, you're getting a steepening, and here you're having a reduction in the gradient of the valley side. And we've just done that within a couple of minutes, thinking of some of the most obvious things that would follow from this single starting point of having more solar radiation on one side of the valley and less on the other. So what I want you to do is think that through, but then develop something like this of your own. And again, I know some of you are trying to think of patchwork items to do each week in this module. So here's something that you could do for a patch. You could do a thought experiment, or even a real world experiment, but certainly a thought experiment based on evidence and based on reading, where you think through the likely impacts of some seemingly small change or difference between two locations in a system, and then work through the components of the system to show how that small change will have knock-on effects that could have big consequences.